All right, ladies and gentlemen, we are looking at two-step equations. We're going to start our two-step equation with a quick review of one-step equations. So here's a one-step equation, x plus 3 equals 8. We call it a one-step equation because you only have to do one thing and then you have your answer. So we talked about doing these one-step equations, and we talked about the fact that on this side we would have the x plus 3. On this side we would have the 8. We talked about putting a line down the center of this right through the equal sign, right through the balance scale. And on each side of that line, putting down what we have in the original problem. So we have on the left side an x and 3 ones. On the right side we have 8 ones, 4, 5, 6, 7, and 8 ones. And then thinking about, we want to get x by itself. That's the goal. How do we get x by itself? Well, the way we'd get x by itself in this circumstance, and keeping the idea of all addition, so everything we do is going to be an addition problem, the way that we would do it is we would add -3. Those 3 negatives would cancel out the 3 positives, boom, boom, and leave us with x. Now, the second rule is whatever you do on one side, you have to do on the other. That's the only way the scale stays balanced. So since we added 3 negatives on the left, we have to add 3 negatives on the right. Let's do that. Add our 3 negatives. Once again, 0 pair, 0 pair, 0 pair. And what's left are those 5 positives. So x equals 5, and we know x equals 5. We know 5 plus 3 makes 8. We still go through, just to make sure we didn't make some careless mistake, we still go through the check phase, and the check phase is where you had x in the original, put in the new answer. So where we had x right here, we put in the 5, add it to the 3. Does that equal 8? You betcha it does. So we know we did that problem correctly. So that is our one-step problem review. I've got a cold going, you can probably tell. So there's our one-step review. Let's put that off to the side here a little bit. Let's shrink it down, stick it on the side. All right, so let's bring another scale out, and let's do a second problem. This time we're going to do a two-step equation. So we'll do the problem this time, 2x plus 3 equals 11. So we're going to bring the 2x plus 3 up here. We're going to bring the 11 up. Let's put our dashed line down through. That's our dashed line to separate out our drawings. It also helps us remember to do the same thing on both sides. So we have our 2 x's. We have 3 1s on this side. Over here we have 11 1s. I'm not going to try to make a line of 11, so I got the first 6 there, leave a little space, do another 5. So there are my 11 ones. And now I'm going to go through with the same goal in mind. The goal is still, what does x equal? And again, you might be able to look at this problem and say, oh, I know exactly what x equals. And that's great. We're building a form here so we can do more complicated problems later. So the first thing we're going to do is we're going to look at this. And the reason we did the drawings was to kind of see what can you cancel out. You can't cancel the x's. There are no x's over here to cancel. But you can cancel the 1s. There are 3 1s here. There are more than 3 1s here. So if we add -3, if we add a -3 here, and we keep in mind whatever we do on one side, we have to do on the other. So we add a -3 here. Let's add it down to these. -1, -1, -1. Over here, these all canceled out. and what we have left over are the two x's. Over here, these canceled out, and what we have left over, let me bring my x's down a little bit because I'm going to need to come down somewhat with the rest of my problem. So what we have left over are 1, 2, 3, 4, 5, 6, 7, 8. We have 8 ones left. So I'm going to put those 8 ones out here. One, 2, 3, 4, 5, 6, 7, 8. Oh, got too many ones. Got one too many ones. All right. So we are going to take the second step. Two-step problem. First step, we got rid of the 3. Now we have to look at the x's. We can't subtract the x's. If we added a negative x to get rid of one of them, so we'd only have one left, we'd have to add a negative x on this side also, and that just wouldn't work. You have to do the same thing to both sides. So we no longer have the option of adding or subtracting something. Besides, we don't subtract anyway. We no longer have the option of adding something. What we can do to get this down to 1x is we can divide it. We can divide it into 2 groups. Because when we divide into 2 groups, we know how much the x is by knowing what half the group is. So we're going to divide this into 2 groups also. We're going to take all of those, and there are 1, 2, 3, 4, 5, 6, 7, 8. We're going to divide that into 2 groups, and that tells us that 1x is equal to 4. When I check my work on that to see if 1x really does equal 4, I do my check. I put in the 4 where I had the x, so 2 times 4 plus 3 is that 11. Now, unlike our check on a one step, which is just one thing, here our check usually takes us 2 steps. So I use the order of operations. 2 times 4 is 8. 8 plus 3 is that 11. You bet it is. Big happy face. Okay. Take a look at that. If you need to re-watch any of that, go ahead and re-watch it. Didn't quite get all the x's there. If there's part of that you need to watch again, watch it again. I'm going to stick it over here, and let's just put a little line down there so you can keep the 2 of those separate. We're going to leave it there as an example, and we're going to work another problem. Now, if you feel like you already know how to do this, you don't have to watch me work the problem. Pause the video, work the problem yourself, and then fast forward to the answer. If you got it right, boy, especially with me having a cold, you don't need to listen to this voice any more than you have to. If you didn't get it right, then go back and watch the steps. All right, let's take a look at our next problem. So this time we're going to go without the scale. 5x minus 2 equals 18. We're still going to put this line down the middle. Now the line's not going to separate drawings. We're not going to draw all of this out, although you could if you'd like to. But we're going to do the same type of steps that we did over here. We're just going to do them now with the numbers and the letters instead of drawing out all the ones. You probably realize that the very first thing you need to do is you need to rewrite this. It has to be rewritten as a problem with no subtraction. We don't do subtraction, we only do addition. So instead of subtracting 2, we're going to add negative 2. This idea of changing everything into addition, this really helps as you move into more complicated problems, and especially complicated problems that involve solving and distributing, where you have to distribute. It's so much easier if you're just doing addition. So the first step is to ask ourselves, what do we need to do to get rid of this amount? This thing that isn't the number times the x, because that's always going to be our first step. First step back here, if we look at the problem we did a moment ago, the first step was, how do you get rid of the 3? And the way we get rid of this is we add its opposite. So the opposite of adding negative 2 is to add positive 2. We're going to do that right here also, adding positive 2. On the left side, when we add positive 2, these cancel out. It becomes 0. It's 2 0 pairs all in one place. And what's left over is the 5x. On the right side, we have 18 plus 2. We get 20. And now we're ready for step 2. Remember, this is a 2-step equation. That was step 1. Here comes step 2. The second step is get x alone by dividing by 5. Why 5? Because if you divide 5x by 5, this becomes a 1. 1 times x gives us x. That's what we want. We want to know what x is. The 20 divided by the same 5 becomes 4. That is our answer right there. X equals 4. How do we know that? Well, we're going to know that for sure because we're going to check. We're going to have 5 times 4, 4 is going where the x was, take away 2 equals 18. When we're doing the check, we're going to leave it as subtraction. We're not going to have that same rule about everything has to be addition. Since the original problem was a subtraction problem, we're going to check it as a subtraction problem. Order of operations, 5 times 4 is 20. 20 minus 2 is 18, and we know that that problem works. All right, let's get ready for another problem. So let's go ahead and shrink this one up a little bit. Kind of stick it off to the side some and get ready to do another. All right, for our next problem, let's do something that has negatives to it because we want to be sure that we've convinced ourselves it doesn't matter if things have negatives, the process is identical. So we're going to have negative 3x plus 4 equals negative 11. Step 1, draw that dashed line down. That's our reminder line. Do the same thing on both sides. Step 2, check it out. Is it a subtraction problem? Nope. Both of these are negative signs, not subtraction, so we don't need to rewrite. So we're ready to solve. So our first thing in solving is, how do I get rid of the 4? Well, I do the opposite. So instead of adding 4, I add negative 4. I do that to both sides. Both sides plus negative 4. That is the first step. When I do that to both sides, on the left, plus 4 and plus negative 4, those cancel each other out, and we're left with negative 3x. On the right side, we have 11 negatives and we add 4 more negatives. That gives us 15 negatives. Remember, don't fall into that trap of negative, negative makes positive. That is only multiplying and dividing. Here we're adding. If you have 11 negatives and you add 4 more negatives, you get a bunch of negatives. All right, step 2, we're going to divide by the coefficient. That's what we call the negative 3. So whatever it is, that's what we divide by. Common mistake here is students just divide by 3. That doesn't work. If we divided by 3, we'd have negative x or opposite x. We'd have another step. So we're going to divide by negative 3. This creates a big 1. You'll know you picked the right thing when you get that big 1. So we have the big 1 there. 1 times x is x. Negative 15 divided by negative 3 is positive 5. How do we know that's right? We know it's right by checking it. So let's go through and check it. We have negative 3 times x, so negative 3 times, we said x is 5, plus 4 equals negative 11. Step 1, negative 3 times 5 is negative 15, plus 4 equals negative 11. And you might have noticed, by the way, let me draw your attention back to something. I bet some of you noticed. Notice the first thing that happens, we get this 20 in the check. It's the same as that 20. Notice we got this negative 15 in the check. it's the same as that negative 15. When you check, you're just going through the problem backwards. So you're going to see the same numbers over again if you did it correctly. All right, then we've got negative 15 plus positive 4. 4 zero pairs. These positives cancel out 4 of these negatives, leaving 11 negatives. You betcha we did it right. Okay, so you've got a couple problems to look at as examples. Now I'd like you to go back to the page where you linked to this video and follow the link to the Khan Academy practice problems, and that's what you're going to work on for the next part of this period.